We don't actually believe AI, that's the be-all, end-all algorithm for intelligent systems. There are other algorithms that will come along. It could also be in the human brain. The human brain only takes 20 watts. The world is worried about the new colonialism through these models coming into their country, because those models code
Value.
Western culture and values, or even Chinese culture and values. There are some jobs that are going to be eliminated by AI. So how do we think about figuring out what's the part of someone's job that they're good at, and what are the parts that machines are good at, and how do we create these hybrid symbiotic systems that get you the best of both?
Welcome to Singapore once again.
Thanks for having me.
What brings you to Singapore this time around?
So we have some work with one of our HII partners here where we're teaching some courses for them. But while we're here, we're meeting with a few key groups. So one is with different government agencies to see about collaborations between Stanford HII and Singapore researchers and government entities, as well as universities, meeting with the university collaborators and potential collaborators.
That's awesome to hear. I noticed that you travel a lot, actually, like to Japan, Korea, what brings you to these places?
HII's mission is really to shape AI for humanity. And we do that through education, obviously, research, policy, and practice, where we work with our industry partners. But when we think about shaping AI for humanity, humanity does not live just in North America or even Northern California. If we really want to shape AI for humanity, we need to engage with other parts of the world where culture is different, where problems are different, where solutions might be different, and learn from each other. And so that's what takes HAI to other parts of the world as we try to develop really a worldwide international consortium of people who are working in human-centered AI.
Wonderful. Given that there's so much demand for AI content these days, right? And Stanford obviously is at the epicenter of a lot of it. How do you decide which topics to focus on, which audiences to focus on, and which countries to focus on the most?
There is a few different criteria that I think of. So one is, besides that original mission of shaping AI for humanity through those ways, we actually have three principles. And those three principles guide, in some ways, how we decide which things we interact with at Stanford or elsewhere and which research projects we fund. So one is that AI as a technology is so powerful, and it has such a power to both improve and harm society, that we need to make sure that design and ethics are involved in AI development, from the planning through development through actual deployment. You can't just do it after the fact and say, hey, did we break something? No, you need to actually embed it all the way through the process. So that's one. So we look to make sure we're doing AI in that way, and the ones we're partnering with are doing AI in that way.
And that would be with engaging with academics, governments, businesses, all of them?
I mean, so there's a lot of people who work in AI who might not care about that. Well, if they don't care about that, then they're not likely to be someone that we're going to collaborate with, or someone that we're going to try to develop in that way. So part of our mission, when we say practice, is how do we help our corporate partners learn how to do this human-centered AI? The second principle is really that although deep learning, this algorithm and this revolution that's been going on, since about 2012 to 2014, so a little over 10 years, has really pushed AI forward much faster than it did over the previous 40 years of AI. We don't actually believe that's the be-all, end-all algorithm for intelligent systems. And we believe there are other algorithms that will come along or be modifications of deep learning. And we look for those in new places. So it could be in other algorithms in statistics and machine learning. It could also be in the human mind, the human brain. The human brain only takes 20 watts. And in my 58 years, I was trained on 1 million times less data in my hearing, my vision, my smell, my taste, my touch than these large models. So there's something going on, even in my dim brain, that is pretty clever. And so we could learn from that for new algorithms, as well as use AI to help us learn about the human brain. And then really the third one is, although AI may disrupt some jobs, there are some jobs that are maybe going to be eliminated by AI, and that's a worrisome thing that we need to make sure that governments are paying attention to, how to help people with that transition, that they did not do a good job previously in globalization. We also think AI will augment people and make them have better jobs and enjoy their jobs better. But we can't just do that automatically. We have to design for it. So how do we think about figuring out what's the part of someone's job that they're good at, and what are the parts that are maybe tedious or boring or things that machines are good at? And how do we kind of create these hybrid symbiotic systems that get you the best of both? And that's a hard design problem to think about how to do that. So those three principles guide where we collaborate. They guide how we fund research.
Wow, that's a lot. Ethics, jobs, and understanding intelligence of the brain more broadly. Is that fair summary of the three things you said?
Yeah, I mean, I'd say the last one in terms of jobs, it's both the economics, but also the design. What is a design process to think about how to make AI augment humans rather than replace them?
Okay. I would love to dive into that. But before I go there, earlier you were mentioning that you engage the world on these three topics.
Yeah.
Has the reception, globally been similar in like different countries you've been to?
It's really important to engage globally because there are differences. There's differences in values. So for example, our AI index that comes out every year around February or March shows what's happening in AI, both in industry, in policy and laws, and also in research. And one thing we find is people's attitudes, the public, towards AI and the acceptance of this automation is really different in different countries and cultures. So in a lot of Asian countries, and even in African countries, you'll find really high rates of positive views towards AI and what's going to happen with AI. Whereas in certain Western countries, especially like the United States, the UK, Australia, you see pretty low levels of acceptance. The gap between them is 30 or 40%. So in the West or in North America, we might think of an AI doctor or AI in medicine, and we might demand, we want it to be 95% accurate, even though, just to tell you the truth, doctors aren't that accurate. But we might have some bar like that, especially for automation. On the other hand, if I'm in a part of the world, a developing part of the world where there's not enough doctors, a system that was 60 or 70% accurate might be very impactful and the public would love, because the option is that or nothing for a lot of people. So again, these values are going to be different depending on the context and situation you're in. And so we can't only think about AI in the North American or Northern California context. We actually have to be out in different parts of the world, talking to different people who have more expertise in the problems in their part of the world, and work with them to be able to shape things together.
America being a big country, honestly, looks at itself the most, right?
Yes.
And I think Silicon Valley being in some ways the center of the world in terms of technology tends to be more, focused on its own problems, right?
Yes.
So I think it's wonderful that you guys are looking outwards.
Well, so that's why I encourage all the students that I advise at Stanford or students I work with to actually go overseas, go live in another country. I personally took a sabbatical where I lived in Beijing for 2.5 years, and that really affected my worldview of thinking about how the different parts of the world differ, but also how living in a different culture and society gives you new ideas because you see the world through a different lens.
I totally agree. I want to go back to the last thing you mentioned, which is that in different countries, the reception towards AI is like vastly different. I did see the report from HAI about this, and I remember seeing, I think, folks in, like, for example, the US, only about 33% of the population or something like that.
Yeah, I'd say 30 to 40%.
Yeah, agreed that AI was beneficial for them, whereas like I think in China and Asia, it was like 70%. And I was a little bit surprised at the numbers, and I was wondering why you think it's so low in the US and why it's so high in these other Asian countries.
So I've seen two explanations. The simpler one that people have used, which I think is actually not good enough to explain this, is they'll say, oh, it's more developing countries versus developed countries have higher attitudes towards AI because AI can have that impact for services they don't have. But that doesn't explain places like South Korea that are very developed, or even Singapore that are very developed that have similar attitudes. So I think it is true, because we'll see it in certain countries that are more developing, in Africa, for example, where there are higher levels of this. But I think the other one is also cultural. So I think in Eastern cultures with more of a almost Confucian collectivist culture, there is actually, I think, also a lift for how AI can help society in some ways that may also push these numbers up. Whether it's Confucian mentality or not is probably the more debatable, but I think it's definitely cultural, and we see it definitely in East Asia, which share often some Confucian underlying cultural collectivism, and maybe something about the collectiveness and the group versus the individual, on that in some ways automation is helping the collective rather than thinking it purely in relation to the self, which I think is more threatening to the self in some ways. Is that robot going to replace me versus is that robot helping us as a group? So that's one possible interpretation, but there's definitely, I think, a cultural component as well as an economic component.
And you think Americans are that afraid of AI because of the potential impact on their jobs?
In a country like America, or maybe even in Australia, there is a little more of this individualistic culture, right? These are two countries that were real rural kind of frontiers, right? And so there's this frontier mythology of, definitely in America, of, the Wild West and, your tough individualistic thing. And I think a lot of people are fearful of two things there. One is job replacement through automation, because we've seen it before. Globalization led to a lot of offshoring of manufacturing away from the United States to East Asia.
Yep.
But it also was not just jobs moving to East Asia. It was also automation in American factories taking away jobs, was a lot of it as well. So there's been a history of automation taking away jobs. And so I think there's also fear, again, that, hey, this technology is coming for jobs. That's one. And then second, more this individualistic kind of anti-government attitude is a very strong American view. Like in America, we don't even have a national ID number because people are worried, the government's going to track me. So AI, I think, starts to be seen as potential surveillance technology.
That's interesting, yeah.
Right? And so I think surveillance technology in a very individualistic society, for good reason, is something that people fear, because AI, computer vision, for example, with cameras everywhere,
Absolutely,
you can track people wherever you want. I think it's broader, and this whole idea of fear of government is kind of against you versus government's here to help you. That's been an American thing for a long time. So these are cultural differences.
Very interesting. I guess for me, it was surprising because a lot of the innovation is coming out of the U.S. So I think that the average person, they'd be like, the U.S. is very innovative and they're very technology forward. Why are the majority, I guess, so fearful?
The United States, if anything, is fairly diverse. You can just look at the founders of the top companies in Silicon Valley. I think,
absolutely,
30% have a founder who's from South Asia, right? So you can have both things being true at the same time.
Yep, very interesting. I think one of the big issues right now, I think, in AI is, where's the power of AI going to lie, right? I think it's wonderful that you guys take a very international approach, but I think not everyone sees it that way, right? They see the US and China really having the majority of talent. Even as a founder and entrepreneur in Singapore, for example, I look at the Silicon Valley and Beijing with some envy, right? Because they have a lot of the talent there. And I can only imagine for governments, that's also something that everyone is thinking about as this power gets centralized. Is my depiction of power being centralized in these two countries a fair one? And secondly, there's a lot of tension right now. Yeah. How do you see this competition, I guess, kind of, playing out in the future?
Yeah, I think there is a huge power concentration. I think it's more concentrated in the US if you look at the top models in terms of performance, but China's definitely caught up or really near the leading edge. And what's interesting is the two countries have done this in different ways. The US has become very closed. The technology is really controlled by some powerful companies like Google and OpenAI and Meta and Microsoft, right? So it's really controlled in companies with a lot of power, and they're not publishing results as much as they used to, so they're locking it down. China, on the other hand, used open source and collaboration and letting people build on top of each other. China was behind in AI, so they moved to open source, and that's what allowed them to kind of get near the leading edge. Now, I think this leads to a way forward for the world. I think There is definitely geopolitical tension between the U.S. and China. The U.S. is worried about China in terms of, are they willing to stay within China, their footprint, or do they want to kind of influence, the rest of Asia or even the rest of the world? China obviously has worries about the U.S. China's worries, I think, are much more historical, having to do with how China was, poorly treated, we have to admit, by the Western powers, in the 19th century. But that's not what the rest of the world cares about. Actually, the rest of the world is probably worried about almost a new colonialism, a new imperialism through these models coming into their country, because those models encode
Value.
Western culture and values, or even Chinese culture and values. Okay. And so how are we going to deal with that underlying cultural values? And I'm going beyond just language here. So we often think of, it's the language you're trained on. That's less important, actually. We can figure out how to translate between language. It's the underlying values that are embedded, or even, as we would say in philosophy, the ontology that's embedded in the model. What does it even mean to be human is embedded from this training. So I think the way to deal with this, and to deal with this, what might be perceived as the new colonialism and this concentration of power, is the model that we had before, which is open source. And I don't mean open weights. So for example, DeepSeek and Llama from Meta, those are open weight models. So you can train the model to change it because the weights you can change. But you don't know what data went into that model. That's like going to the grocery store and buying a package of something and there's no ingredients. And you might say, well, I don't know. I'm not sure this is good for me. Until we know what's in these models, you don't really know if it's good for you. And so we really need open data, open source models, so that we can start to ask questions about, for example, if I train this on a lot of Western data, and now I start training it on, let's say, data from South Korea, how much does it take before I start to see Korean cultural values be the dominant values versus Western? I can't really understand that with open weight models. We have to actually understand it by starting from the ground up. So I advocate open models, open data, and a collaborative consortium across the world with different countries and cultures where we can work on those kind of problems together.
So you're almost proposing two paradigms, right? One is what we're kind of seeing already, which is some consolidation of power amongst the big companies. And, a lot of it in the West, as you said. And you are proposing, forget about China for a second, that open source models in general will offer a counterweight to some of this consolidation of power. Do you think that the balance is going to be struck in the future?
The Chinese models are only partially open source. So, they're open weight, but they did publish a lot in a white paper for DeepSeek, for example, on algorithmic things they did, but only part about how it works. They kept many other parts very secret, just like the Western companies have done. And so I believe that, open source and open data will truly help us move forward better than either of those. Now, that's not to say doing this is going to break the domination of those companies. I think it's more of a yes and. Those companies, and maybe China and big companies in China, they're going to have a majority of what the commercial market uses. But I think by opening up what researchers can do across the world, the public sector, and even small companies and startups, by creating open source, open data, we can get them to be able to compete in many ways. Will they overtake the big guys? Probably not in general, but for certain segments and certain sub-problems where you don't need the biggest, most leading edge model, other models will actually maybe fit your problem better or be sufficiently large for what you're trying to do. So I think it's yes and. We'll get some of both. And so having that diversity will be good.
Very interesting. It actually reminds me of the time at least I grew up in, which is like a very social media dominated age, right? And there were two arguments back then, right? One is that the diversity, like social media allows everyone to have a voice now. Whereas back in the day, it was the big publishers who basically dictated what you said. And I think social media has allowed lots of fringe voices to come up. But at the same time, a lot of these big companies have actually ended up dominating these social media platforms.
When the social media stuff happened, I think government regulators decided, hey, let's let the industry regulate themselves. We don't want to stifle innovation. Well, how well did that turn out? Those are actually AI, to tell you the truth. What Instagram shows you or what Facebook shows you in your newsfeed, those are AI-mediated algorithms deciding what to show you. And so I think those are just the early examples of how AI led to no agreement on what's true, or AI led to people feeling bad about their body image from some of this, or AI leading to addiction in gaming for some people by showing them exactly the thing that they might most want and saying, hey, it's available for 24 hours, buy it now or never buy it in your life, right? So AI has already been used in those previous things in a bad way. And I think the lesson is that industry will not easily self-regulate, and that there needs to be a balance between, asking industry to try to do the right thing, because industry is made up of individuals who mainly want to do the right thing. But the incentive structure of capitalism is just such that a company is in the end going to try to maximize the
profits,
returns and the profits to the shareholders and their leaders, who are often paid that way. And that's probably what we want, because that actually leads to a lot of economic health for a lot of people. But on the other hand, we also need to know that regulation has always been what true market economies have as well, to kind of make it sane. And I think social media showed us that it needed some regulation. And I think AI is going to be the same. We're going to need some regulation. Now, there's a balance, like how much regulation? The regulations that we've seen so far proposed are probably too extreme. And they're based on what my colleague Fei-Fei Li says, science fiction rather than science. We want science, not science fiction. And so we need to make sure regulation is based upon the actual science of AI and where it's going, rather than science fiction nightmares of where it's going.
Do you think regulators understand this enough to regulate it? Things are changing so rapidly. How do we create regulation that, makes sense, given that people don't even really know how this is going to play out?
So I think it depends where you are in the world. For example, here in Singapore, the regulators are actually pretty well educated about AI and the technology behind it. On the other hand, if you look at the US Congress, hearings on Capitol Hill showed us that these senators didn't even understand how Facebook or any of these things worked, right? So in the US, that gap is probably more of an age gap. Many of the legislatures in the US are really old, especially in the United States Senate. So, there's actually solutions to this. So for example, HAI, for over 7 years at this point, has a congressional boot camp where congressional staffers come to Stanford for a couple of days and get a crash course on AI, what it can do and what it can't do. Because one of the big problems is people just, again, believing science fiction instead of what are the limitations and what is the trends. And so we're really trying to educate the staffers, because they're actually the people who write the legislation, not the actual Congress people. We've done that also with ASEAN foreign ministers. We've done a lot of consultation with EU regulators. And I know in the state of California, they just announced a program that seems to be kind of modeled on some of our programs to have essentially non-government organizations, NGOs, help train state legislative staff in AI to help, again, base legislation on science, not science fiction.
Awesome. Actually, I'm very excited when I see what HAI is doing in this regard. I also wanted to spend a little bit of time talking about your other, passion / personal interest, which is in the area of human-computer interaction.
Okay.
And I, read your background. In the very beginning, you started devising, different ways for humans to really use devices.
Yeah. So when we founded HAI over 7 years ago at this point, and really it's the planning for it started 9 years ago, it was originally myself, Fei-Fei Li, who's one of the most famous people in computer vision, and also her ImageNet challenge kind of helped kick off this deep learning revolution. And then Chris Manning, who's one of the most famous people in an area of AI called natural language processing. And you might go, well, those two I get, they're AI people. Why is James Landay in this crowd? And the reason is I've worked in human-computer interaction, and so that human-centered part is kind of the part that I really kind of grabbed onto as where my contribution in this lies, and was really influential in holding that. Many of the projects that I do in this area of human-computer interaction are about envisioning what is a future of how we will use and relate to technology. So what's the technology going to be in 5, 10, 15 years? And if I look back at my career, 80% of those projects that I've done, including my PhD, involved AI under the hood being the real juice that allowed this new vision to happen. So actually, as a researcher, it's sort of frustrating, because many of these things we did were cool and we showed how they could work, but they never actually all came to fruition because the AI never worked well enough. Now it's been flipped. It's like, oh, all those visions that we've had, we can actually make them real now and really test them for real. So it's been exciting to go all the way from my PhD that was about sketching user interfaces with an electronic pen. And then those sketches were recognized by the computer and they literally became alive as sketches. So you would draw a user interface and you could click on these hand-drawn buttons and all these things and it would actually work in an electronic screen, even though they look like sketches still. Like today, people could build that, in 5 hours with a large model. And that's a lot of what I'm working on now is how is the way we're going to work with computing really change over the next 5 to 10 years?
Tell me more. If you were Johnny Ive or, not Johnny Ive, but James Landay, right? Designing new devices for the future.
Yeah.
What would it look like?
Yeah. So one is even to admit the way we communicate is not just through language. So a lot of computer scientists and AI people, in fact, will think, oh yeah, it's language. Now we have language. That's how we're going to interact with computing. But the fact is, language is only a piece of how we communicate. My hands have been moving. If I was looking at you instead of at this camera, there would be a lot of eye contact and other gestural movements. There may even be pheromones in the air. Like there is a lot of things going on. And that's even in a thing that's really focused on language, like we're conversing. Now imagine I'm trying to talk to a computer or communicate with a computer is what we really mean, right? Some tasks, language is a really efficient way to tell a computer what I want it to do. But imagine on the other hand, if I'm designing something that's visual and I'm manipulating it, how it looks or how it behaves, sometimes language is not the easiest way to describe it. So imagine trying to do a drawing purely while talking and get it exactly how you want. That's actually really hard. And that's where, the pencil or the pen or the mouse that has what we call direct manipulation has worked really well. So the future of our interaction is what we call multimodal. We're going to use voice. We're going to use gesture. We're going to use tools. I'm even going to use the keyboard sometimes. We're going to use all those things together often and sometimes in conjunction with each other and sometimes in substitution from one another, depending on what so we're going to use different modalities. If I'm designing something visually, I might use some voice and use some direct manipulation together. I might say, make that thicker as I draw it, right? That would be multimodal. I'm doing both the modality of drawing and speaking about what I want at the same time. That is more likely how we're going to interact. And depending on your contextual situation, it will change too. So in the classroom, versus I'm walking down the street, you've seen people walking down the street with their phone. That is not the safest thing. Knowing that you're moving, you're going to change the interface. Knowing that you're driving, you're going to change the interface. Knowing that I'm sitting in an office, I'm going to change the interface again. So understand the situation. Knowing that I'm cooking, I'm probably not going to want to have to click on stuff while I'm cooking. I'll want to talk, but I might also want to gesture. Hey, when's that done? Or order me a pizza like that one over there that I got last week. So I want to even go across multiple devices all together. And I'm probably going to have today's AI agents embedded in these different things in my environment, working together with me to achieve what I'm trying to do.
So is one way to imagine this, there could be a software that basically captures all your needs, your preferences, that's in the cloud. And then within your house, maybe you have multiple smart devices that basically you interact with, right? Because right now, if you think about it, we're still kind of limited by a few things, mostly our phone and iPad, but you don't really see it being embedded throughout the house, right? Like in the kitchen, I'm not really, using AI with any device. If we want to think about AI today, another thing it can do is companionship. Let's say companionship for my kids. Do I want them to be holding on their phone and computer all the time? Maybe not. Maybe they want to hold onto their soft toy. But I don't really see that being embedded and not really designed in a way where, it's like one brain, multiple hands almost, right? Is that coming?
So there's two different things here. One is, what is the underlying physical and software architecture to make all these devices work together? There's different ways of doing it. It could just be you have all these individual smart devices, and because they're smart, you can interact with them.
Yep.
The other way is just, you figure out the engineering to make them talk to each other in different ways.
True.
So that's how we implement it. That's been hard to do, but I think AI also makes that easier because it can get around some of these interoperability problems. But I think the other problem holding it back has actually been a design problem. So if I was the designer and trying to think about how do I allow you to do this task you're trying to do across your iPad, across your laptop, across that big screen TV over on that back wall of your kitchen, I had to anticipate all the different ways you might interact. And if I want language, all the different ways you might say the thing you want to happen. That grows what we like to say in computer science exponentially, very large and fast. And it makes that programming task and that design task impossible. You couldn't have done it. So that's been the other part that has held back this vision that people in the research field have had for 30 years. Now, what's interesting, and a student I had just finished his PhD, Jackie Yang, showed that with today's large language models, they can deal with a lot of that, figuring out all the possibilities, whereas then the designer can just focus on the high level idea, and the low level interpreting what the user said and interpreting what it means that we designed for allows this to scale. So AI working today is what's going to unlock that future of being able to interact across these devices in a more natural way.
If I think through what we're using today, it's like a very, very 1.0 version, if it's even like 0.1 version.
Of
right?
AI, you mean?
Not just AI, but like in terms of interfaces.
Yeah, so our interfaces.
Like literally it's a computer and the phone, right?
Yeah, I mean, our interfaces that we're using today date back to Doug Engelbart's 1968 demo, the mother of all demos, as it's called, in San Francisco in 1968. So pointing with a mouse, Windows, things like outlining, version control, remote communication and networking. Like, he invented so many things that are in our interfaces today. They're slightly more sophisticated. His thing was black and white. His thing only had characters and not graphics. But the basic ideas were there, and then they were further developed in the Xerox Star in the early 70s, and then copied really and improved yet again in the Apple, Lisa, and Macintosh in the early 80s. What did the iPhone give us? It gave us all that in a mobile device that had networking on the go and used 2 fingers instead of 1.
Exactly.
It's still fundamentally the same ideas.
Yep.
Pointing, clicking on objects. The question is, are we ready for the next big change?
So far, it's been very much, as you and I agree, it's like, really the computer, except in different sizes, really.
Yeah.
Right? In the next 5 years, 10 years, 20 years, how do you see us interacting with AI physically, I guess?
So again, I see us using language. I see us using body. I see us using tools. I see us using the context of what we're doing, or even that activity, physical activity I'm doing in the real world. You have little tastes of this now, right? The fact that my watch or my ring understands that I went running, or understands that I went dancing, or that I went to yoga. Those are steps of understanding your real world physical context. So AI and sensing, all that's going to help us understand more of our physical context. That's what I'd call implicit input. And then combined with explicit input, so me talking or me gesturing, those 2 types of input are how we're going to interact with computing. And both AI makes both of those things become more and more powerful and more across the different places and situations that will use computing to interact. So that's what's going to change. Instead of these small islands that we carry or wear on our bodies, it's going to be more and more coming together.
Last question on this topic, which is, who do you see becoming the main leaders in this? So OpenAI is like working with, now hardware developers to do stuff. You could argue maybe it's the companies that have been really great at doing, smart home devices, because they, literally have devices all around your home already, right?
So I think there's kind of 2 trade-offs here, right? Small companies, startups are really great because they move fast. They don't need 20 layers of decision-making to do something. They can take risk and they can fail, and other ones can succeed. So we've seen always a lot of great innovation there. But this kind of new interface, at least that way I'm imagining it, it's not an island. Like, we've seen these pins fail. We saw, in the 90s, the Palm Pilot. It was sort of like an island, or the Apple Newton. They connected, at least the Palm Pilot connected to your PC, but it still was sort of an island, and it kicked off what I think would be the smartphone. But I think those island things have a hard time spreading across everything we do. So that's hard, I think, for a startup to do. And so I think there is an advantage, at least for this vision that I see of the future, for the companies that control platforms. So, that's the Googles, that's the Apples, that's the Microsofts. for doing this. And so the question is, will it be the platform guys or will it be these AI folks? I personally think the platform folks have an advantage because they have the customers and they have the platforms where they can make changes at low levels in the operating system that support it. And those other companies, startups or OpenAI, they don't control a platform unless they do it in collaboration. So maybe OpenAI does it with Microsoft, maybe. But I think it's going to be pretty hard for them to build their own hardware and take over everything because they just don't have the generality to do it. Whereas is their AI better than Google's? Like they're pretty comparable. So I personally, if I'm betting, I bet on one of the platform companies. We're often right on what's going to happen because we are really about living in the future. That's like the key trick in computer science is how do you predict the future by predicting the trends and going to where the puck's going to be. But we're not always so good at exactly knowing when that's going to happen because sometimes that's dependent on price. It's dependent on the market being ready, all these other things that are more often business problems.
Interesting. But I think this conversation at the very least has sparked my, sparked my thoughts on how is this going to pan out, right? Because as you said, we've made a lot of progress on the big data, large language model front. But in terms of human computer interaction, honestly, it's just devices of different sizes and mainly using my, one or two fingers, really.
Right.
It's not using my brain in terms
Your
of
whole
a neural
body.
link. It's not using my physical manipulation of things. And it certainly isn't, besides my phone, which follows me everywhere, but it's certainly not interacting with me as I said, it could be toys, for example, for children. For adults, it could be, who knows what it is, right? It could be something else. So why is it also limited?
Well, I think you bring up a neural link or any other kind of neural interface, like we did an interface over 10 years ago, which was on your wrist and could sense your fingers. And then eventually another company copied that idea. And then eventually Meta did it. And now they have something that's closer to product. So these ideas often start in research. They take many years to really get there. And now we have these neural ones that, again, I'm not going to drill a hole in my head for it, but eventually maybe we get something that you wear in a hat. And so I don't think that there will be one ring that rules them all, one interface that rules them all. It's kind of diversity of different ways.
Yep. Well, this is a whole discussion in itself. And I think to learn more, you have to follow Professor Landay's courses at Stanford. I guess one last question for the audience, which is, we have a lot of entrepreneurs who want to do good. And they're wondering what kind of things they should be building going forward. You yourself have kind of been an entrepreneur teacher, right? You sold a company at one stage.
Yeah.
What advice would you have for entrepreneurs now? And how can they maybe, link up to the resources that you guys provide to kind of get inspiration for what to do next?
Well, first of all, it's great that people want to do good. And, there's a real, I think, a change in the students, let's say, from the 90s to today of really be focused on, I want to do something that has positive impact on the world versus just, hey, I want to make money. But what I like to give a talk, I say it, AI for good is not good enough. A call for human-centered AI. What that says is you can't just have the intention of doing good. You actually need to think about what's the right way to build AI applications and systems that are more likely to have a positive impact. And the problem is the ways we've thought about designing user interfaces and applications in the past, an area we call user-centered design that, my career has been totally in that field and trying to cause companies to use user-centered design in their work. That's a field that dates back, 40 or 50 years, depending when you want to start the clock. But it's only in the last 15 or 20 years that the tech industry, at least the big players, actually have embraced that methodology of involving users in designing their interfaces and testing and all of these things. But what's different is AI is a technology that affects people beyond the direct user, whether it could be the community around that user. Like some AI systems are made to make decisions about a community. Like, for example, where did I put fire resources in Los Angeles? Maybe I used AI to position them. Or do you get some life-saving technique that's on the leading edge for medical research, or does this other person get it? That decision-making is sometimes made by AI. You're not the user. It's somebody else who's the user, but it's affecting your life, but I don't design it around you. Or even people who are labeling training data for these large AI, they're actually affected by the material that they might have to look at, whether it's like pornographic or other kind of material that would be stressful to read or see, or just by being dependent on their income on some big tech company in a foreign country that can change their policy of where they label their training data and throw you out of a job like that, right? So that larger community needs to be involved in design for AI because they're impacted. And then finally, if your AI system is really successful, you might impact society. So think again about that Facebook newsfeed, which has led to people questioning what's true or false and affected democracy in the United States, in Brazil, and other countries, may have led to the genocide of the Rohingya people. Those are things where AI has actually had societal level effects because of how ubiquitous those applications are. So we want to also think about, what does it mean to do societal level design? How do we think about if what I'm working on actually becomes so successful, what could the negative effects be? And how might we mitigate those effects? Now, as you think about this idea of user-centered, community-centered, society-centered, and integrating across them, you might say, damn, James, that sounds really hard. And you're right, it is really hard. But it's especially hard for computer scientists who don't have any training to think about analyzing at this community or society level. And that's why we really need to change who's working on these systems. Yes, we need AI experts, technologists, designers, but we also need social scientists, humanists, even artists, folks who are used to thinking about these other levels. And they should be interdisciplinary teams that have some of each of these expertise working together. And that's how we're going to create AI systems that are going to be more positive.
Very interesting hearing you say that. And just to share a personal anecdote, I'm someone who's always starting companies, right? And in the recent years, I've been like, what company do I want to start next? And, sitting in front of a computer using AI tools has been very inspiring. But at the same time, it's actually been kind of limiting in some ways. And I've often found that the way to actually inspire myself on how to use AI has actually been to go back into the human world. Be it like playing with my child. And playing with my child has inspired ideas around AI toys. Be it doing more work in the nonprofit and community sector has actually given me ideas for gaps in there that I can actually leverage AI for. So I've almost had to retreat from my computer to actually go back into the human world to get inspiration for actually how to leverage this technology in order to even be beneficial to anybody and have users. I think it's really great that someone is thinking about this, and I think that's the role that Stanford HAI places, which is, you're kind of at the intersection of thinking about societal implications, but also being technologists who really care about that. I think that's really exciting. So thank you for doing that.
Yeah, I think you just observed a key thing is having a child really causes one to think about learning and intelligence, because you actually get to see it happening in real time with your child.
Absolutely.
And then it also gets you thinking about what is good and what is the future of society that you want for that child.
Absolutely.
And I actually think some of these bros in Silicon Valley probably do a lot better if they had children to have that bigger view of the world than, hey, it's me, a tech guy who's kind of in my own world.
It's funny, I was watching an interview with Sam Altman, actually, and he said, a lot of my friends keep saying to me, I'm so glad you just had a baby. That makes me feel better. And he said, I don't think it actually changed me in any way. But, although I obviously love having a child, but I think most of us think that, it may make some difference to him. And we are glad that he had a child recently. So I totally get what you're saying. All right, it's been almost an hour. Don't want to hold you back, but thank you very much, Professor Landay, and we look forward to having you hopefully in the future again.
Thanks for having me, and glad to be back here in Singapore, which I think is the leading edge of things happening in Asia.
Wonderful. I'm very excited, and to be honest, I'm also very proud of what our government is doing. So I'm very excited that our government's doing such great things, and you are over here, interacting with local regulators as well as local business people as well.
Great.
Thank you.
Thank you.